In this video, let us discuss about hierarchical agglomerative clustering using complete linkage method. In the previous video, we have seen that in complete linkage, the intercluster distance is the distance between the farthest members of the two clusters. Let us see an example. For the given set of data points, find the clusters using complete linkage technique. Use Euclidean distance and draw the dendrogram. There are 6 points which lies on the two-dimensional plane with xy coordinates. This shows the graphical representation of the points on the xy plane. The formula to compute the Euclidean distance between 2 points P1 and P2 is given as the square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. First, let us create the distance matrix. Distance from P1 to P1 is 0. The Euclidean distance between P1 and P2 is square root of 0.40 minus 0.22 square plus 0.58 minus 0.38 square. It is equal to 0.23. Similarly, compute the Euclidean distance between all pairs of points. In this problem, we are going to use complete linkage technique. Find the smallest distance. It is 0.10. This is the distance between the points P3 and P6. Merge P3 and P6 to form the first cluster. Let us draw the corresponding dendrogram. Now, we need to recalculate the distance matrix. To obtain the new distance matrix, remove the entries of P3 and P6 and replace it by a new entry P3, P6. Compute the distance between the cluster P3, P6 and all other points. Since we are using complete linkage clustering, the distance between the cluster P3, P6 and every other point is the maximum of the distance between the point and P3 and the point and P6. Let us compute the distance between P3, P6 and P1. Find the maximum of the distance between P3, P1 and distance between P6, P1. The distance between P3, P1 is 0.22 and the distance between P6, P1 is 0.24. The maximum value is 0.24. Add this value to the matrix. That means the distance between P3, P6 and P1 is 0.24 using complete linkage. Similarly, we compute the distance between P3, P6 and P2. It is 0.24. The distance between P3, P6 and P4 is 0.22. Distance between P3, P6 and P5 is 0.39. And the last cell is 0. This is the updated matrix after first clustering. Again, find the smallest distance. It is 0.14. It is the distance between P2 and P5. So, the next cluster formed is between P2 and P5. Let us draw the dendrogram. Recalculate the distance matrix. Now, P2 and P5 are in one cluster. So, remove the entries corresponding to P2 and P5 and replace it with a single entry P2, P5. Calculate the distance to P2, P5 as we have done earlier. Distance between P2, P5 and P1 is 0.34. Distance between P2, P5 and P4 is 0.28. Distance between P2, P5 and P3, P6 is 0.39. Distance between P2, P5 and P2, P5 is 0. Here is the updated distance matrix. Again, repeat the steps. Find the minimum value. It is 0.22. It is the distance between the cluster P3, P6 and P4. So, P3, P6, P4 together forms the next cluster. Update the dendrogram. Recalculate the distance matrix. Replace separate entries for P3, P6 and P4 with a single entry for P3, P6, P4. Calculate the distance to other points to the new cluster. Distance between the new cluster and P1 is 0.37. Distance between the new cluster and the cluster P2, P5 is 0.39 and the last cell is 0. Here is the updated distance matrix. The smallest value is 0.34. It is the distance between the cluster P2, P5 and P1. Make the new cluster P2, P5, P1. Update the dendrogram. Recalculate the distance matrix. Replace the entries for P1 and the cluster P2, P5 with the new cluster P2, P5, P1. Calculate the distance to the new cluster. The distance between the new cluster and P2, P5, P1 is 0.39. The last cell is 0. Here is the updated distance matrix. Join the two clusters to form the final cluster. Update the dendrogram. Here is the final result of the hierarchical agglomerative complete linkage clustering.